anything which is not supposed to do. There are two solutions, AdSave and Facebook JavaScript, which have led to the development of Kaha, which is, I think, the superior solution, and I will discuss it in more detail. Kaha is basically a Google project which provides object capability security in JavaScript while trying to make as few changes to the language as possible. So how do they do it? You can basically provide Kaha, or the Kaha compiler, with a web application, and it will verify whether the code does something it's not supposed to do, and when possible it will try to rewrite the code, introducing runtime checks to ensure that at the client side you cannot do anything harmful. Out comes this changed web application which provides you with the wanted security. The advantage of having a subset of JavaScript with some removed features is that it allows reasoning about the language, and this reasoning can be used to provide stronger security guarantees, such as proving formally that a subset is indeed secure. And this is research that has been done by Sergio Maffei, which will present it in another track later on today, I think. So Kaha is successfully used on multiple websites, such as the Yahoo application platform or iGoogle, which allows you to create a mashup of multiple components. A second approach on the interaction level is not trying to separate modules or scripts from each other, but trying to enforce some control over their behavior. So what you can try to do is say, for instance, I don't want a script to communicate to external servers. I only want it to have some interactive effect on my website, for instance. So the techniques I present here are academic results, which means that they have been presented and evaluated, but are not yet used on a wide scale on the internet, for instance. The first three techniques are kind of similar in the sense that they provide the same functionality. They try to provide a developer with the mechanism to enforce a policy on a specific script. Of course, each technique has its different approach and different peculiarities, but they basically allow you to specify a policy with a script. The browser will check that this policy is indeed enforced, or the browser will weave the policy with the code, so it is enforced at runtime. And you can basically control the behavior of the script. The final technique, secure multi-execution, is a technique which which enforces non-interference on specific scripts, and this non-interference is basically the fact that you can ensure that unauthorized data will not flow to that sensitive data will not flow to unauthorized parties. A third item we needed to fix was to enable communication, and this can be done. The problem here is that the same origin policy does not allow communication to different origins than the origin where a script or a page came from. And again, mashup developers have been really inventive and have found workarounds to fix this problem. The first three are workarounds. The final one, cross-origin resource sharing, is the design solution and enables cross-domain communication similar to XHR in JavaScript. This is done supplying additional header information. So the server tells the browser whether a request was allowed or not, and the browser will ensure that it is enforced similar to the same origin policy. So basically, the browser denies access to the content of the response if a script was not allowed to have access to that content. Important here is that the design has taken legacy code into account. So by enabling this cross-origin communication, applications not supporting this communication should not become vulnerable. And this has been done in a good way, which I cannot explain in detail, unfortunately. Important here that this course is also about to be standardized. So it's a W3C working draft, and it specifies the API and the algorithms, but not an implementation. So you're free to implement it how you want, either as XHR or as a separate API, such as Internet Explorer has done. So far, for the techniques which are currently being standardized or being developed in the academic world. So to revisit the example we have are different components which can be separated using either the sandbox attribute, which is strong enforcement, or Kaha modules if you want script inclusion. We have enabled interaction with other components using post message. and we have enabled interaction with external components with cores. Finally, we also provide behavior over the control of scripts, either using KH in some form or the policy-based techniques or non-interference techniques, which actually affect the behavior of the scripts. To conclude, I want to discuss a bit about the future of mashup security. Probably, as you have concluded from this presentation, mashup security is extremely complex because there's a lot of things to take into account. You have a lot of origins, you have a lot of components which need interaction, and the current techniques provide a strong basis to enable this foundation, but we still need abstractions for them to become really powerful, because if you want to do it right now, you have to do it all yourself. You have to take a specific technique and you have to edit, so you have to combine several techniques yourself, and this might be hard. So what we can do, or what we should do, is to look into the real requirements of mashups in the sense of security. What security requirements are important? Which business requirements do we need? And the business requirements are the key here, because businesses, for instance, take a financial mashup or an e-health example. They have compliance against different sort of contracts. They have privacy regulations to take into account. And they might want to provide a mashup if they can guarantee this, this security. And what happens here is that, or what might be happening is that we go to a policy-based approach. And this policy-based approach allows you to specify a mashup policy. And this mashup policy is provided with the application and controls several fine-grained aspects of this, this mashup application, for instance, the isolation or the restriction. And using or enforcing this policy can ensure mashup security in a strong way. But to achieve this, you need the cooperation of the client and the server, because in a mashup, the enforcement point is most likely the client, but the policy should be provided by the server. And one of the major difficulties here is if you have multiple providers of components, how do you combine a policy, or how do you specify a policy for the combination of all the components together? And I think that's one of the major research challenges in the future. I've also included the references mentioned in the presentation at the end. And if you want to ask some questions, I'll be happy to answer them. Thank you. Yes?
I missed what regarding authentication. How you have some specific message protocol to inform an application regarding user name, credentials?
Yes, so you're asking whether there's some form of authentication between mashup components, right? Or between...
I guess the user should authenticate for only once, and then you should somehow to transfer the knowledge between applications.
Yes, so to rephrase the question, you're asking if there's an authentication mechanism allowing for a sort of single sign-on mechanism for the entire mashup. Okay, I think this might be possible with the current single sign-on mechanisms, but it's not something we have investigated in this research. But you should be able to achieve this if you have, for instance, a single sign-on service like it exists today, but used by the different components together. So the mashup application itself could provide some authentication mechanism, but I don't have anything specific on that, I'm sorry. Yeah.
So I was wondering if you were looking at differences for client-side and server-side mashups and security policies.
Yeah, so the question is if there are any difference between client-side and server-side mashups for policies. So indeed, there is a distinction between the client-side and the server-side mashup, which I have left out in this presentation intentionally, because the line between a client-side and a server-side mashup is very thin. So basically, a server-side mashup is a mashup where the server combines all the components and gives you one page which contains everything. And a client-side mashup is where the server gives you a page which references all the components and is put together at the client side. So one major difference between those approaches is that the server-side mashup basically has no restrictions of the same origin policy. Everything ends up within the same origin of the server providing it. And this makes security particularly difficult since you don't have anything to build on. On the side of security policies, I think it will be harder in a sense to enforce it on a server-side mashup since you have nothing to build on. I don't know which direction you want me to go with the answer. Is there something specific you have in mind?
No, but just for the requirements you identified, like separation, integration. So what you identify any clear differences if you are server-side or client-side?
Well, in the requirements, I think they're largely within the same constraints. For instance, if you have a server-side mashup, you combine several components, but you still want them to be separated. And at the time, this is not really possible since you don't have any same origin policy anymore. What you can do is start creating subdomains for every component, which is actually how some approaches work. And then you can build on the same origin policy again to create this separation. Maybe this can be improved using the sandbox attribute for iframes to ensure that even within the same origin there is separation. But requirements-wise, as far as I know in the research that has been done now, there are not many differences that need to be taken into account specifically. Yeah.
I mean, the differences of a business context versus end user. You could say in a business context, you could take into account different SLAs between different parties combining in an enterprise mashup. Whereas if you say you want to include policies of the end user, it will be much more specific that end users don't want this data to flow into that component. So I think there might be differences in the policies in specifying it at high level. Low level technical, I think it will reside into the same kind of issues in combining those policies together. But from a business context, I think you have different ways of identifying policies. Makes sense.
Yes, of course. What the audience member was saying is that there are differences in how a business will construct its policy and how an end user will define a policy. For instance, the end user is concerned in not having his data leak to other origins or other sites, while a business user or business provider really wants to ensure that that there is compliance with specific policies or regulations. And that might indeed differ since end users only see the front end of the mashup. So what they want to restrict is typically based on this front end view, and businesses typically want to ensure that their back end remains safe and want to enforce this through the front end. Any other questions?
Just a remark, if you have a server-side mashup, you can do a lot of filtering on the server. So you could put them in the same origin, but check what is the code of the mashups you're combining and maybe enforce some policy that way.
Yes, this is actually what, for instance, Facebook JavaScript does. Oh, sorry, to repeat the question for the recording. So if you have a server-side mashup, you can ensure some kind of policy by applying filtering. And this is true, but one of the difficulties with web applications is that on the server side, you don't have full context. So basically, the right place to evaluate, for instance, JavaScript is in the browser, because the browser knows how to interpret all the JavaScript and knows what is exactly meant by this JavaScript. And filtering can be used, for instance, by Facebook JavaScript, which uses some form of filtering and rewriting for its scripts so that it ensures that it's secure. But as long as you don't have a formal model behind it, it will be very hard to get right, as is shown by several problems with in the Facebook JavaScript specification, for instance. But you can try to provide some policy, but recent research has concluded that the client side is probably the best place to try to enforce JavaScript policies due to the complexity of the language and the good interpretations browsers make, since they have to run it, they have to understand it. Okay, so I think my time is nearly up. If there are no more questions, I would like to thank you for your attention and feedback.